over here to a blank page. And this seems to help more than anything I've ever done in the 18 years of teaching to help students do factoring. We're going to do the X factor, okay? So we're going to take a big X, and somewhere on your paper, draw you an X. Okay, a quadratic form is ax squared plus bx plus c. All right, so this is a quadratic expression. When I put equals 0, it's a quadratic equation. Okay, so a is a coefficient of x squared, b is a coefficient of x, right, and c is our constant. Okay, so what we're looking at today is factoring when a equals 1. Now, this is going to work on both when a is 1 and when a is greater than 1. So I want to get you in the habit of doing this so that when tomorrow we do a is greater than 1, it won't be a problem. All right, so on the X, you're going to, up the top, you're going to put whatever a times c is. You're going to put that there. And then whatever b is, you're going to put here. And then you're going to draw 2 fraction bars, and underneath it, you're going to put a. Okay? So on the top, you're going to put whatever a times c is. On the bottom, you're going to put whatever b is. And then to the side, your denominator is going to be a. So if I have x squared plus 6x plus 5, all right? So we're going to say a equals the coefficient, right? So a equals 1. B is the coefficient of x, so b is 6, and c is 5. All right? So here we're going to put a times c. So 1 times 5 is 5. And then on the bottom, we're going to put b, whatever b is, which is 6. And then here, we're going to put what a is, which is 1. All right? So you're going to look for the factors of 5 that are their sum is 6. Okay? The factors of 5 that the sum is 6. All right, factors of 5 that add up to 6. So my factors of 5 are going to be 1 times 5, and that's it, isn't it? All right, so I can say 1 times 5 is 5, and I can say 1 plus 5 is 6. So that fits. It's factors of 5, 1 and 5. So I can multiply them and get 5, and then I can add them and get 6. Okay, always check to make sure that that's working out. You multiply them and you get that. You add them and you get that. Okay? All right, so let me erase a little bit here so we can have some room. All right, so now I'm ready to get my 2 binomials, because we know a quadratic expression factors to 2 binomials. Okay? All right, so you're going to take this number and divide it by whatever your denominator is, which is a. So divide it by 1 and you get 1. 5 divided by 1 is 5. So you're going to have your variable's x, right? So you're going to put x, and over here you got a positive 1, so put plus 1. Over here, you got a positive 5, so put x plus 5. Okay, so that's your factor. Now you can check it. X times x is x squared. And that's 5x. This is 1x. And this is 5. Combine x squared plus 6x plus 5, which is that. Okay. All right. Now don't start going, oh, I can't get it. You're gonna have to try a few before you get used to it, okay? Okay. Today we're gonna start factoring quadratics, okay? And this is a big part of the quadratic section, and you've got to know how to factor to do any of the quadratic problems. All right, so this is real important. We've talked about simplified form and factored form. So when we've got two binomials, like right here, that is factored form, okay? So to get the simplified form, we've been doing the full method, or distributing. X times x is x squared. X times 5 is 5x. And then 1 times x is 1x. And 1 times 5 is positive 5. Combine your like terms, which are usually the two middle terms, and you come up with x squared plus 6x plus 5. All right, so this trinomial is the simplified form. It can be factored to two binomials, all right? So you would say that this trinomial is the products when you multiply, right? Product of these two binomials, okay? Trinomials like these can be factored back into the product of binomials. So that's what we're going to be doing today, is they're going to give us the simplified form, and we are going to factor it back to two binomials. All right? Now, I'm going to kind of just be patient. All right. So let's look at the first one here. What is A going to be? And you have to make sure they're in proper order from standard form, from square to first power to constant. So A is 1, B equals 9, and C equals 20. All right, so we're factoring, right? So first I want to make sure, can I pull out any greatest common factor? No, because this is 1, so we know it's going to be 1. Excuse me, y'all. All right, so I'm going to do my x. And on the top, I'm going to put A times C. 1 times C is 20. And then down here is B. And then we're dividing by A, which is 1. So the factors of 20 that add up to 9. So the factors of 20 are 1 times 20, 2 times 10, 3 won't do it, 4 times 5. My next number is 5, and I've already got it over here, so that means I've got all my factors. So which of these, if I add them together, would equal 9? So this would be 21, this is 12, 4 and 5 is 9. So this is the numbers I'm going to use, 4 and 5. So 4 divided by 1 is 4. 5 divided by 1 is 5. So here, my variable's n. So n plus 4 and n plus 5. And that's going to be your answer. And again, you can check it by distributing your full method, and you should end up with this. N times n is n squared plus 4n plus 5n plus 20. These combine to be 9n, so we're good. All right, let's try this one. All right, we said A is 1, B is 10, and C is 24. So at the top, we put A times C, so 24, and at the bottom, we put B. And we're always dividing by A. And in today, A is going to be 1, all right, because that's all we're looking at, is when A equals 1. All right, so factors of 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 won't go, 6, so that's all of them. So which of these equal 10? It would be 4 and 6, right? So 6 divided by 1 is 6, 4 divided by 1 is 4, and my variable is A. So put A's at the front, plus 4, plus 6. And that's your answer. Okay, why don't you hit pause and try number 5. Okay, you want to see how you did? All right, we said that A is 1, B is 3, and C is, negative 18. I should have might have tried to do this one first before you try to negative by yourself. All right, so A times C, so 1 times negative 18 is negative 18, and then B is 3, and our denominator is A. All right, so we're looking at the factors of negative 18. So that could be 1 times negative 18, could be negative 1 times 18. It could be 2 times negative 9, or negative 2 times 9. It could be 3 times negative 6, or it could be negative 3 times 6. 4 won't go, 5 won't go, so that's all of them. So we need to look and see which one of these pairs, when we add them together, equals 3. Well, this would be negative 17, and this would be positive 17. This would be negative 7, positive 7. This would be negative 3, and this would be positive 3. All right, so you got to watch your signs on these. So negative 3 and positive 6. So negative 3. So our variable's n. So we got minus 3 or negative 3 and positive 6. Now let's look and make sure. N times n is n squared. N times 6 is positive 6n. Negative 3n and negative 18. 6 plus negative 3n is 3n, positive 3n. So it does match. Okay, so when you're looking at those factors, you have to consider your signs. And whenever you've got, this is a plus and this is a minus, your signs are going to be plus and minus. Okay. All right, let's see. You can hit pause and try this one. All right. So we said that A is 1, B is 1, C is negative 6. So 1 times negative 6, and B is 1, and we're dividing by A, which is 1. So factors of -6, you got 2 and -3, and -2 and +3. Well, if I add these together, I'll get +1, right? So they're going to be -2 and 3. So it's going to be G minus 2 and G plus 3. So good deal. On this set, positive, negative, then you're going to have a positive, negative.
Mr. Troball.
But since the middle number's positive, then your larger number's going to go with positive. That way you'll have a positive number. And then when they're both positive, then it's going to be plus plus. Okay?
Mr. Troball.
Let's flip this over. Let's look at when we've got two minuses here. So we got A is 1. You do the same way, you just have to watch your sides. B is -2 and C is -3. So our A times C is -3 and B is -2. So -3 times 1, or either it's -1 times +3. So this would add up to -2. So that's our numbers. A minus 3 and A plus 1. All right. Let's try number 13. A equals 1, B equals -11, C equals 24. Okay, in this case, the middle number is a negative, and this number's positive. So we're doing A times C, which is positive 24, and B is -11. So in this case, your factors of 24 are both going to have to be negative, right? Because it has to be negative times negatives positive, but they got to add up to be negatives. So we can do -1 times -24, because we're trying to get -11. -2 times -12. Not working, is it? -3 times -8. Well, those will add up to -11, won't it? So -3 and -8. So x minus 3, x minus 8. Okay. Right. This is a mixed set, so all it's doing is before we had just positive, positive, then we had positive, negative, then negative, negative, and then negative, positive. So you just have to remember to watch your signs. On this, whenever your middle numbers are negative, you're going to have negative, negative. Whenever your both of them are negative, then you're going to have one of them's going to be positive, one of them's going to be negative, but this is going to be the larger number is here with the negative. With the okay. So this is just a mixed. But let's look at one. You know how I said GCF? You always look to see if you have a GCF, right? Okay. They were nice enough in the ones that we've been doing that there wasn't a greatest common factor. But in real life, most of the time there is one. Okay? So, as I said, whenever your doing any type of factoring, you always look to pull out a GCF. You always check to see if there's one. First off, you need to have a complete factor form. Second, it saves you from trying to find the factors of a large number, all right? When you take that greatest common factor out, it makes your numbers smaller that you're factoring, all right? So always look for a GCF first. So let's go back to finding GCF. 4, 12, and 8. What's a common factor? All right, always look at your smallest number first and see if that one will work. If it doesn't, then it's going to be something smaller than that. All right, so our smallest number is 4. 4 will go into 12, and it will also go into 8. So 4 is going to be our common factor. How about K? All right, they don't have another K on the constant there. All right, so let's do our X. 4 times, oops, my bad, I needed to finish this for you before I do that, don't I? Kind of got ahead of myself. All right, so let's finish the greatest common factor. So divide each term by 4, so it'd be K squared plus 3K plus 2. So now you're looking at the factors of 2 that add up to 3. Well, we know that one's pretty easy. 2 and 1, right? So your answer is going to be bring down this 4 and then your 2 binomials. K plus 2 and K plus 1. Okay? Your GCF goes in there as well. All right, 3, 15, and 12. My GCF is 3, right? So it'd be 3 times y squared minus 5y plus 4. All right, so now we're going to factor this. So A is 1, B is -5, and C is 4. So factors of -5 that add up to 4. All right, so we know that since B is positive, that we're going to have our bigger number positive. So let's 5 and -1. If we add those together, they equal positive 4. So 5 and -1. So bring down your GCF. And it's going to be y plus 5 and y minus 1. You say, well, does it matter if I do 3 times y minus 1 and y plus 5? It's the exact same thing, all right? Remember, the commutative property order doesn't matter when you're multiplying, okay? So it doesn't matter, we're multiplying here, so these are all factors. So it doesn't matter what order we have them in. In fact, this 3 could be in the middle here. It doesn't matter. All right, and let's do this one last one here. Looking for GCF, 2, 10, and 12. So I'm going to look at my smallest number, 2. 2 will go into those, so my GCF is going to be 2. So I'm going to divide each term by 2. B squared plus 5b plus 6. So now we're going to factor this. So A times C. 1 times 6 is 6, and then B is 5. And we're dividing by A, which is 1. All right, factors of 6 that add up to 5. You say, well, 6 times 1. But 6 plus 1 is 7. And our signs this is positive, so it can only be -6 times -1 or 6 times 1. So both of those are either 7 or -7. But we also have 2 times 3, don't we? And 2 plus 3 is 5. So my answer is gonna be, bring down your GCF. And our two binomials will be b plus 2 and b plus 3. Okay. All right. Try to do the other problems for practice, and then you'll have your individual practice for classwork. All right, y'all have a good evening. Bye-bye.